Hi guys, in this YouTube video I'll be teaching you how to make a machine learning model which is intelligently able to classify a piece of text as spam or not. Usually in our day-to-day lives we have emails coming in and some of these emails are spam, and most of the email clients which we use have a active spam filtration feature built in. So we're gonna be building a basic spam filtration model which attempts to do a similar task as the email clients we have. So here are some sentences. Assume these sentences are emails or something, and then the first few sentences are actually not spam. Something like, hi Sam, how was your day? Or please forward the details about your job to me. All these kind of messages, well, they are not really spam, but on uh, the next few sentences, something like hurry, huge sales and offers on top brands, or your account has been selected for a lot of prize money. These kind of messages are usually spam, right? So the first thing we need to do to get started with our machine learning model is, well, to collect lots and lots of data. So I found this link online which had a bunch of emails categorized as spam or ham. Ham basically means the good messages or the not spam messages, and there are around 1,500 items here, and there are around some 3,600 items here. So let's have a look at a spam message. So, do you care? Them, so, work, game, meet, expect, describe, red, figure. I don't know. So, these are some random spam messages, and these are some ham messages. And what I've done is I've taken all of these emails and put them into one big folder called emails. And yeah, I've posted the link to the dataset in the description below. And yeah, let's get started with writing code. I'm just going to increase the font size here. So I have a Python program called spam.py, and the way we're going to approach this problem is, I'm going to break it down into a few steps. So the first step would be to convert all this text data into a format which our program understands, and the format which our program understands is numbers. So we need to figure out a way to convert all this text data into numbers. So the first step which we need to do is to make a dictionary of all the words which the computer needs to know in order to process all these emails. So what we're going to do is we're going to read all of these emails in the emails folder. We're going to read all of these emails, and we're going to put all the words which we encounter in these emails into a list. So that's the first part. So in order to do that, I'm gonna first import OS, and then I'm gonna set my directory. Let's call it direct or something. Directory is emails, and emails is equal to os.list dir of direct. So I'm gonna take out all the emails in that directory, and once I have that, I can start processing my emails. So let's append the directory name to the file names. I think the better convention would be to call this files, and then emails equals direct plus email for email in files. So there's some quick list comprehension going around. Basically what this does is it just appends the directory emails to the file names. So this list would contain the paths of all the files. So once we have that, we can say for email in emails, I'm going to read that email. So f is equal to open the email, open open the email, and then read the email. So f dot read, and let's just save it to a variable called blob or something. So blob equals f dot read, and when we have that, we can actually keep a track of all the words we know by having a list called words, and then appending the blob to that list. So words plus equals blob dot split at space. So I'm going to split the blob at spaces, and I'm going to append it to words. So the directory words, I'm sorry, the list words will have all the words which we encounter in all these emails, and there will be, duplicate words also, and we'll take care of that a bit later. So in order to see how the processing is going on, we can actually have a counter and initialize it to the length of all the emails, the number of emails we have, and then we can print that, and then we can reduce it by 1, c minus 1. Yeah, and let's print emails. I'm sorry, let's print words. So let's see how this program runs out, and I can say Python spam.py. So as you can see, it's reading all of these files right now. It's already read 2000, 3000 files, and, and that's the huge list of words we know right now. So let's ignore that for a while. Let's not print it, and let's try to find a way to to delete the duplicate words, and also to extract the most common words which we know. So yeah, these are all the words which we know, and there are a lot of repeats in these words. So let's take care of that also. So there's something called a counter which is there in the collections library. So from collections, I'm going to import counter. So a counter basically does exactly what we want. So I can say like a dictionary. I can make a dictionary, and I can say counter, and I can put the words list inside that, and then I can print counter dot most. I'm sorry, dictionary dot most common, and let's say the most common 3000 words. I can print that. So dictionary will is actually a counter. It's an object of the class counter, and it has an attribute called most common. So this can print out the 3000 most frequently used words in our words list. And actually, let's also add another line here which eliminates all the non-alphanumeric words like numbers or hyphens or any symbols. So for I in range len of words, if words of I I forgot, I think it's dot is alpha, then if it's not an alphabet, then I can replace it with, say, an empty string, and then before I do the most common thing, I can delete dictionary of that. So this is just a simple way to get rid of all the non-alphanumeric words, albeit it's a very not the most efficient way to do it, but it's fine. And I can run the program again, and there's invalid syntax, so it's probably not. And I'm not sure if there's a function called as alpha, but we'll find out soon enough. So again, we're reading all these emails, and yeah, so that's our most common 3000 words. So let's scroll up and let's have a look at what this means. So the most common word we have is the, and the occurs 22,000 times, and then the next most common word is to, and that occurs 16,000 times, and then so on. So these are the 3000 most common words, Although we don't really need the frequency of each word, I don't think it hurts to have them, so it's fine. So now that we have the most common 3000 words, I I think it'll be a good way if we actually enclose this in a function. Um, so let's try to do that. Actually, let's make it all into a function, and let's call this function I don't know, def make dict. Oh, def make dict, and we can put all of this into here, and then just add that line which we missed out. Direct equals emails. Yeah. So now that we've made this into a function, and instead of printing, we would want to return it. What happened there? Yeah, return it. So yeah, so we return the dictionary. So with this, our first step is over. So now moving on to the next step, we need to make a data set. That is the next step. So we're going to be using a supervised learning algorithm, and for that we need to somehow make all of this data into a data set which which gives the computer, or which gives the program an idea of how to go about fitting it fitting all the data into a machine learning model. So in order to do that, there is this technique known as feature vectorization for words. It's similar to the bag of words model. Big words, we don't really care about that. Let me just get on to the crux of it. So here is what I was talking about. So we have a dictionary. So we made a dictionary, right? We just made a dictionary, and that dictionary looks like this. So we have a dictionary, and assume we just have a few sentences like the ones we saw at the beginning of the video. And so these are the different kinds of words, and these are the frequency with which the word occurs in our data set. So this is a dictionary which the computer knows, and then we need to make a feature vector. The feature vector will be a mathematical way of representing a string, right? So assume we have the sentence, send me some money for groceries. So the feature vector for this would look exactly like a snapshot of the dictionary, except that the numbers will be something like this. So for occurs once in the sentence here, and money occurs once in the sentence here, and the other words, send me and groceries, don't occur, so we have no track of that. uh, Obviously, as the dictionary size grows, we can accommodate more and more words. In this simple example, we don't, so it's fine. So this is how we can encode a sentence as a feature vector. So the next step would be to make a data set by making all the emails, all the text files into feature vectors. So let's try to do that, and we'll enclose that in a function as well. So we can say make data set. Make data set given the dictionary would be a good way to go. So I have the dictionary, and now yeah. So I have the dictionary, and now I need to make data set. So I have to iterate over the emails folder all over again and process the emails one by one. So I can say I can just copy actually the few lines from here. I can copy I can copy all the way till here. Let's just copy till here, I guess, and then paste it here. So I'm reading the emails once again, and for email in emails, I'm gonna open it again. I'm gonna open the email again, and this time I'm gonna take out all the words. F equals blob equals f dot read again, and I'm gonna split it at spaces so I have all the words. Actually I can just call it words, I guess, this one. So all the words in this particular email are stored in the variable words, and then I can have a, instead of having this here, I can have a data, actually I can have a data list, and then for, let's figure out how this would go. So I need to go over the dictionary and then append a 1 or a 0 if it occurs in our email or not. So for entry, I guess, I don't know, entry in dictionary, data dot append words dot count of entry of 0. Since entry is a dictionary element and has both a key and a value pair, the key is the word and the value is the frequency. So we are interested just in the words, so we can just say words dot count entry of 0. So we're going to count how many times uh, the word under inspection in our dictionary occurs in our email, and whatever that number is, we append it to the data. Now actually we can initialize this data instance for every email, and then we can have another feature set as another email, and then after the entire processing of the email is done, we can append data to feature set. So I can say feature set dot append data. So for every email I convert the email into a numerical form, and after I convert that email to a numerical form, I add it to my feature set. So this is basically what we are doing. As I gave the example earlier, this is the conversion of the email into a feature vector. So now that is done, maybe while we're at it, we can also have we can make a labels list, and if the particular email in under inspection, if that email, uh, if ham in email, so if the word ham is there in the name of the email, all the text files have a nomenclature of naming, and if that email is a spam, then it has spam written inside its file name, and if it's not a spam, that is if it's a ham, it has ham written in its email. So if ham in email, then I can just say labels.append 0, all right, uh, and then else, or maybe just to be sure, I can also have an if condition. So if spam in email labels dot append 1. So I'm going to append a 1 if the current email is a spam, and I'm going to append a 0 if it's not a spam. And also we can print our tracking variable c and decrement it by 1 for every time in the loop, and then we can return the values which we generated, that is feature set and labels. And now actually I guess we're done, so we can call these functions which we just made. So we can first make the dictionary. I'm gonna say d equals make make dict, and then I can also make the data set. So features and labels equals make dataset, and I'm going to pass in the dictionary which I just made, and let's actually print the length of the features and the length of the labels, and in on a very ideal condition, these two numbers should be equal because they denote the same thing. So let's run this and see what we've gotten. So I'm going to clear out this, and I can say python spam.py, and let this run. So now it's the first half, it's reading the files, and then this process is going to start over again like it just did right now. And this time it's actually making the data set. It's going over each email, it's converting that email into numbers, and then making a feature set out of that. So our program just finished executing, and as it's visible here, both these numbers which we've printed, they are equal, and they're supposed to be equal because they denote the exact same data set. The dimensionality of features and labels is the same. So this denotes the end of part one of our expedition to filter out spam messages. In the next part of this video, we are going to be digging into the machine learning part of this whole project, and that is where we're going to train our model, and that's where the actual machine learning lies. So this was a pre-processing which which has to be done in most machine learning applications. So yeah, so be sure to check out the next part of the video. Thank you.